All right, first up here, we're going to do number 2. So this one is a tutorial exercise. So the kind of first question it asks is sine is an even or odd function. Sine is an odd function, which means that sine of negative x, we can take that negative and move it out front. And so that's kind of the first step here. So what they're going to say is we can call this, we can turn this into negative sine of 11 pi over 12. So we can take that negative and throw it out front. All right, so then the next step, we're going to split this up into 2 angles, and I think they give you the first angle here. So for me, they give me pi over 4 plus, and then you kind of have to figure out what's going on in there. And so what I would do is I would do 11 pi over 12, and then I would subtract this pi over 4. However, I would do it with a common denominator, so that would be 3 pi over 12. And so that's going to give me 8 pi over 12, which will reduce by 4 into 2 pi over 3. And so with that, then I can split this up into negative sine of pi over 4, cosine of 2 pi over 3, and now what I'm using is the angle addition formula right here. However, since we have this negative out front here, it's actually going to apply to both, and so that's why that second one is also a negative. It would be addition here, but that negative really distributes into both of them. And so then this one will be in here, cosine of the first thing according to that formula. So that would be pi over 4 times sine of, what would that be? 2 pi over 3, just the second thing. All right, so then our next step is to go to the unit circle. And from there, we're just going to evaluate each one of these. And so this one looks like it'll become negative, and then sine of pi over 4 would be rad 2 over 2. Cosine of 2 pi over 3 would be over here as negative 1/2. And then we'll go minus cosine of pi over 4 would be also rad 2 over 2. Sine of 2 pi over 3 would be the y value there as rad 3 over 2. Now over here we have a negative times a negative, so this one will actually turn into positive, and I'm going to move over here for this last step, or last 2 steps. So positive rad 2 over 4, and then minus rad 6 over 4, and so that'll become just rad 2 minus rad 6 all over 4. All right, next up here we're going to do sine of 195. So what we want to do is think about 2 angles on the unit circle that we know that we can use to split this up. And so I think I would probably use, let's see, what would I use? I guess we could do 150 plus 45. That would work. There's a lot of other combinations you could use, but I'm going to use 150 plus 45. So I know what both of those are. I'm kind of looking at this point here and this point over here. And then I can use my angle addition formula to break that up. So that is going to be sine of the first thing times cosine of the second thing plus cosine of the first thing, and then sine of the second thing. And then we'll go to the unit circle, evaluate them, and multiply them together. So after that, it's gonna look very similar to the last question. So this would be 1/2, and then rad 2 over 2, and then this would be negative rad 3 over 2 and rad 2 over 2. So this will become rad 2 over 4 minus rad 6 over 4. So rad 2 minus rad 6 all over 4. All right, next up here we got a tangent problem. So for this one we want to break this apart again. So I'm going to do it as tan of 30 plus 45. And so then we can use our tan formula. Let me pull that up here. All right, so I'm going to be using the angle addition formula for tan. There are other ways you could have broken that up and use the angle subtraction, but the way I did it is angle addition. So what I'm going to do then is do tan of the first thing plus tan of the second thing over 1 minus the 2 tangents multiplied together. All right, so now I need to kind of on the side here figure out what is tan of 45 and what is tan of 30. So tan of 45 is pretty easy actually. It's rad 2 over 2 over rad 2 over 2, so that's 1. Tan of 30 is 1/2 over rad 3 over 2. And if I multiply by the reciprocal there, that's going to be 2 over radical 3. And those cross cancel, so that's going to be 1 over rad 3. You could rationalize that denominator. I'm actually not going to, since I'm going to do some more work with this. So I'm just going to plug that in here. Plus tan 45 is 1 over 1. And then on the bottom here, I'll have 1 over 1 minus tan 30 times 1. Okay, so kind of the first thing I'm going to do is I multiply these two together, but obviously that 1 is irrelevant because it's multiplying. So I'm just going to scribble it out there. You can think of it like I did multiply that by 1, but like I said, it is not going to change it. And so now what I need to do is some common denominator up top. So I'm going to multiply this by rad 3 over rad 3, and then same thing on bottom. So I get 1 plus rad 3 over rad 3 over rad 3 minus 1 over rad 3. So now I'm going to multiply by the reciprocal here, so times rad 3 over rad 3 minus 1. And so then you see that these rad 3's do cancel out there, but I'm left with 1 plus rad 3 over rad 3 minus 1. And I really should practice rationalizing this denominator, so I multiply by the conjugate, which is rad 3 plus 1. And so on the bottom, I need to do a fl, and so that'll be first times first is 3 minus 1. So first times first and last times last. You can always do that for conjugates. On the top, though, I need to do a full FOIL. And so I'm going to say that that is first times first is rad 3. Outer times outer is 1. Inner times inner is 3. And then last times last is rad 3. So that's going to simplify into 4 plus 2 rad 3 over 2. And if I divide everything by 2, it's going to just become 2 plus rad 3. All right, next up we have a cosine here, and for this one you can see that it's been given to us in radians. Now I never really like doing these in radians. I always think it's easier to switch them to degrees, so I'm going to do that first. So we're going to multiply this by 180 over pi. So obviously the pi's cancel out, and need to do 180 divided by 12, and so that is 1 and minus 12 is 60, so that'll be 15. So now I have 15 times 29. So that's 5 with a 4, and then 13, okay. And then this will be 30. So that'll be 435. So this is really asking for cosine of 435. After that, we got a couple of options here. We could subtract 360 to find a coterminal angle if we want. However, since we're going to be using the addition and subtraction formula anyway, I can see right away this can be written as 135 plus 300. So I'm just going to do that since 135 and 300 I do already know. If you do find that coterminal angle, you should end up with the same answer by the time you finish the question. So a couple of different ways to do this one. All right, so then next step then is I'm going to use the angle addition formula for cosine right here. And you got to be kind of careful with this one because when it's adding in there, it is actually going to be subtracting when you expand it here. So I got cosine of 135 times cosine of 300 minus sine of 135 sine of 300. So then I have, let's see, all right, go to the unit circle. Cosine of 135 is negative rad 2 over 2. Cosine of 300 is 1/2 minus sine of 135 is rad 2 over 2, and then sine of 300 is negative rad 3 over 2. So these ones up here are going to multiply by each other and get negative rad 2 over 4. This is actually a negative times a negative, so that's going to turn into a plus with the rad 6 over 4, and so that'll be negative rad 2 plus rad 6 all over 4. All right, next up here, I'm going to be doing number 8, and that's kind of similar to number 7, so that'll help you with that. Let me get my formulas. All right, so first thing I want to do on this one is, it looks like it's kind of the expanded version of one of these formulas. I'd say it looks very much like the expanded version of this formula, and so I'm going to switch it back, kind of going that direction. And so I can kind of put this all together here as sine of 13 plus 32, which is actually, if you add those together, just sine of 45 degrees, and make sure you do put the degree symbol there. And after that, I can just go to the unit circle, which I'm just going to draw a quick one right there. And that's rad 2 over 2, comma rad 2 over 2. So actually, whether it was sine or cosine, it would be rad 2 over 2. All right, next up here, once again, we're going to use our formulas. So let me pull that up. And I need to identify which formula this is looking like, and I would say it's looking like our sine, or I would say it's actually looking like this one right here. And so we're going to switch it back that way, kind of just like we did last time. So it's going to be sine of the first thing minus the second thing. And so now I'm going to kind of multiply these, or sorry, subtract them with a common denominator. So we're going to multiply this by 3 over 3. So this will be 9 pi over 21 minus 2 pi over 21, which is 7 pi over 21, which would just reduce to pi over 3. So this is all just sine of pi over 3. All right, and then we look at the unit circle, and so pi over 3 is up here, and the y value there is a big Y value. It'll be rad 3 over 2. All right, next one here, we are again kind of using a formula backwards. I see that kind of all of this together looks like this formula right here, so I'm going to move it back into that version. So it's all going to turn into tan of pi over 18 plus pi over 9. Once again on this one, I would just add this together with common denominator, call that 2 pi over 18. So this is all tan of 3 pi over 18, which can reduce to just tangent of pi over 6, which is what they want here. So then the next piece, I would go to the unit circle. So pi over 6 is right here. The coordinates are rad 3 over 2, comma 1/2. And so the tangent would be 1/2 divided by rad 3 over 2, which if we multiply by the reciprocal would be 2 over rad 3. And that'll be 1 over rad 3. And so we get rad 3 over 3. All right, next up here, they're wanting us to prove this identity here. So for tan of pi over 2 minus u, they actually split it into sine of pi over 2 minus u over cosine of pi over 2 minus u, which is obviously fine. Anytime we have a tangent, we can change it into sine over cosine. So then we can split apart both of those using the sine and cosine formulas. And so looks like the only piece that's missing up top here is sine of pi over 2, because you can see it's sine of pi of the first thing times cosine of the second thing minus cosine of the first thing, sine of the second thing. So then I know, according to the unit circle, that sine of pi over 2 being 0, 1 is obviously 1. And so then I see up here that this 0 times, or negative 0 times sine of u is obviously going to turn into 0. So I'm just left with cosine of u. And then I have cosine of u over sine of u, which is cotangent of u. All right, I skipped a few questions in the middle there. They are very similar, and I'll do kind of one more here. So once again, they are breaking this apart using our formula. And so it looks like the only thing they're missing is the tangent of pi down here. Now on the unit circle, pi has the coordinates of negative 1, 0. So the y over x tangent of that would be 0 over negative 1, which is obviously 0. And then they kind of skip a step here, but what I would say up top there is that this is tangent of x, obviously, because anything minus 0 is just itself. And then on bottom, if I multiply these two together, it is 0, and so that cancels out, and I'm left with 1, and that will result in just a tan of x. All right, next up here, we got another identity that we're trying to prove. And it looks like they broke these apart kind of separately here. And so the only piece I'm missing on this first one is coming from the tangent of x minus pi over 6. Or sorry, not tangent, cosine. So that is cosine of the first thing, cosine of the second thing. So that'll be cosine of pi over 6. And then they have the rest of that filled in, and they also have this filled in over here. Now I need cosine of pi over 6. Now pi over 6 is right here with a coordinate of rad 3 over 2, comma 1/2. And so the cosine then would just be rad 3 over 2. And so what I kind of notice then is that, all right, so then what I notice here is that we kind of have, this is all one term right here, cosine of x times rad 3 over 2, and then this is that same term but negative, so negative cosine x times rad 3 over 2. And anytime we have the the same term, positive and negative, they'll obviously cancel. And then that same thing happens here with our sine of x times 1/2 and our negative sine of x. They cancel out as well, and so we are left with 0. All right, next up here, we're going to prove this identity. And so it looks like what they did is they expanded that one right here. And so I'm going to need to expand this one over here. So it's going to be sine of the first thing, cosine of the second thing, minus cosine of the first thing times sine of the second thing. Okay, and so what's really important here, and you can see that they drew this negative with a parentheses, I need to distribute this into the two terms here. So this is actually going to become negative sine x cosine y plus cosine x sine y because of that negative in front of the parentheses. And so then I'll rewrite all this stuff out front. All right, and so now I'm going to combine like terms. So it looks like sine x cosine y, I have one of each, positive and negative. So those are going to cancel. And then cosine x sine y, they are actually both positive. So that means I have, and actually this is my final answer, 2 cosine x sine y. All right, next up here, once again, what did they do here? Okay, so they have this piece really is right here, and so I just need to do this piece right here, and so that's going to be, man, they did not give me enough space here. Okay, so we're going to go sine of x cosine of y according to the formula, and then this is a minus, and so I'll do it up here. Actually, that'll be cosine of x sine of y, and that is a minus in between. Okay, so then once again here, I want to distribute the negative from this one, and I will write that up here. So this is going to become a negative sine of x and cosine of y, and then it'll also become a negative cosine of x sine of y. And so once again here, I need to group my terms up. So I have positive sine x cosine y, which will match up with this negative sine x cosine y, which will cancel out. And then I'll have this as a negative cosine x sine y, and then this is also a negative cosine x sine y, so this will be negative 2 cosine x sine y. I think they'll need parentheses in there probably. Okay, so then next up we can start canceling. So I can cancel out the 2's. However, since that top was negative, it'll still be a negative right there. We can cancel out cosine x's, and then I am left with a sine y over a cosine y, and so that'll end up as a negative tan of y. All right, next up here, you can see that they actually on this one worked on the left-hand side. That wouldn't have been my choice, but that is what they did. And so they took that left side and they actually multiplied it by the conjugate here. Conjugate multiplication is kind of never a terrible idea. And so you can see that they already took care of the bottom. They did a fl there. They did the Mr. Berry fl, and they ended up with that. And so I need to take care of the top, which is 1 plus sine times, oh, actually it's 1 plus sine x squared. Oh, they actually did not FOIL that, so I'm not going to do that. Okay, so then what they did is they turned that 1 minus sine squared into a cosine squared. And then since the top and the bottom were both squared, you can actually just write this now as cosine x on bottom, since this squared would now apply to everything. And then they didn't show this step, but what they kind of did is split this up into 1 over cosine plus sine over cosine, which is how they turn that into secant and tangent. All right, next problem here, it looks like they are working on the right-hand side. So the only thing they're changing here is that cotangent. They also changed cosecant, so that's obviously going to be cosine of theta. Now they did the common denominator up top, so I need to do the common denominator on bottom. So the common denominator would obviously be sine of theta, which is why this one got multiplied by sine if you look at the next step. And let's see what they did next. Okay, so sine squared minus 1 Well, we know that 1 minus sine squared is cosine squared. And so if that gets flipped around, then that would turn into negative cosine squared. So that's what this one is. Now they already have the negative out front, so I'm just going to put cosine of theta. And you can see they already have the squared up there, and they already have the negative in front. And so what did they do next? They just canceled out this cosine down here with one of them up there. So we're left with a cosine that is no longer squared. And we get our final answer.